We all know that sun ages the skin. It is one of the first things that we learn in aesthetics. Up to 80% of visible facial aging is due to UV exposure. But as advanced practitioners, we need to move past the simple statement that sun causes wrinkles, and we need to understand the exact cellular mechanisms driving that process. In today's video, we're going to look at the biochemical reality of photoaging. We're going to connect the dots between UV radiation, the activation of destructive enzymes like collagenase, and the surprising role of cortisol in accelerating the entire process. Let's start with the extracellular matrix, the structural scaffolding of the dermis made primarily of collagen and elastin. In a healthy, youthful skin, there is a constant balance cycle of breaking down old collagen and synthesizing new collagen. But UV radiation, specifically UVA, completely disrupts this balance. When UVA penetrates the dermis, it generates massive amounts of reactive oxygen species or free radicals. These free radicals trigger a signaling cascade in fibroblasts and keratinocytes. They essentially flip a switch that upregulates the production of matrix metalloproteinases or MMPs, and MMPs are a family of enzymes that are responsible for breaking down proteins. The most critical one here is MMP1, also known as collagenase. And as the name suggests, its primary role is to cleave and destroy collagen fibers. So UV exposure causes a spike in collagenase. But it gets even worse, unfortunately. So let's have a look. At the exact same time that UV radiation is upregulating these destructive enzymes, it is simultaneously downregulating the synthesis of new procollagen. The skin is breaking down its structural support faster than it can actually rebuild it. So over time, this leads to the accumulation of fragmented, disorganized collagen fibers. This is the microscopic reality of what we see on the surface as deep wrinkles, solar elastosis, and loss of firmness. Now, let's layer in the neuroendocrine connection because the skin does not exist in isolation. Okay, when the body is under chronic stress, it produces elevated levels of cortisol. Cortisol is highly catabolic. It breaks down tissue. So high cortisol levels directly inhibit the proliferation of fibroblasts, which are the cells responsible for producing collagen, and it also decreases the production of hyaluronic acid. So if you have a client who is chronically stressed, their skin is already struggling to maintain its structural integrity. When you combine the chronic stress with UV exposure, you create a perfect storm for accelerating aging. You have UV radiation driving up collagenase to destroy existing collagen, and at the same time, that elevated cortisol that is suppressing the fibroblast ability to produce new collagen to replace it. The degradation pathway is wide open and the repair pathway is blocked. So understanding this mechanism changes how we treat photoaging. It's not just about applying SPF to block the initial UV trigger. We need to intervene at the cellular level. We need potent antioxidants to neutralize reactive oxygen species before they activate MMPs, and we need ingredients that support fibroblast function and collagen synthesis. And most critically, we have to address systemic factors like stress that compromise the skin's ability to repair itself. Photoaging is an active, enzyme-driven process of destruction. Our job is to understand the pathway from UV to ROS to collagenase, so that we can build comprehensive barrier-first protocols that protect and rebuild the skin's architecture. I hope you enjoyed this video, and I look forward to see you next week.